Hey everyone, I'm going to make a quick video here showing how to multiply using the area model or the grid method, sometimes called the box method. So let's do a 2-digit times a 1-digit number. I'm going to show kind of like the traditional way and how it compares to the box method. So students have already learned how to find an area of a rectangle when you multiply the length times the width. We can use that concept to help build meaning when multiplying larger numbers beyond their basic facts. So the first step to the area model is to break 79 down into expanded form to show the value of each digit. So 79, since it's the larger number, goes along the larger side, and 8 is going to go on the short side. Now, over here, when we do this traditional way that most everybody, including myself, learned when we were in school, the problem with it is that it does not build number concepts or really reinforce what you're doing when you're multiplying. This way here, you're thinking about the value. So what do I mean by that? If I start with the smaller fact, which we do first here, 8 times 9, we know that 8 times 9 is 72. Then when we do the next digit, if I know 8 times 7 is 56, I know 8 times 70 would have a 0 in it, so it's 560. The last step is to go ahead and add these partial products. So the answer to this multiplication problem is 632. Okay, how does it compare with here? I get 72 and I carry the 7. Then we do 8 times 7 is 56, and then we need to remember to add 7. So we multiplied, then added what we carried, and we get 63. It's still 632, but when I did this, it was basically learning an algorithm, memorizing steps, and not even thinking about the numbers really at all. When I went here, I said 8 times 7. I wasn't even thinking that, well, this isn't really 7. It's in the tens place. It's 70. So what I try to have my students understand is how to think about reasonable answers. If 8 times 70 is 560, then I know my answer has to be over 560. Let's look at a 3-digit. Let's do 435 times 6. When we do the box, we need to separate into 3 places because it's a 3-digit number. We put 435 in expanded form along the long side of the rectangle, times it by 6. So when we find the area of each of these sections and put it all together, we would know the area of this rectangle or the answer to this multiplication fact. So if I start here, this time 6 times 4 I know is 24, but I'm timesing it by 400, so I know my answer to this problem is going to be over 2,400. 6 times 3 is 18, but it's 6 times 30, so that's 180. And lastly, 6 times 5 is 30. I just need to add it to put it all together. My partial products give me a final product of 2,610. Once students have a firm grasp of the number's value and what they're doing when they're multiplying these numbers, then we move on to this. So very shortly, students will be learning the algorithm. 6 times 3, 18, 19, 20, 21. 6 times 4 is 24, 25, 26. Yes, this is faster, but for students who are first learning, multiplying, remembering to multiply 6 times all of these numbers and also adding while you go as the shortcut is sometimes just confusing to them. That's why we like to show them the value, multiply them all, and add at the very end. You can also do this with 4-digit numbers and 2 digits by 2 digits. I will have a video for 2 by 2, but I just wanted everybody to understand kind of the why behind why we do this and how it helps build understanding before we move on to this way. I hope this helps. Thanks.